All right, we're going to do problems 1 through 5 on review day 13. First one gives us particle in motion given by this equation, and we're asked to find which one describes the motion of the particle at 1. So we're talking about velocity in terms of whether it's moving up or down, and acceleration in terms of whether it's increasing or decreasing. So first off, let's find velocity. That's 3t squared minus 8t plus 4. If we were to put 1 into that, we'd get 3 minus 8, negative 5, plus 4, we'd get negative 1. So we're moving down, not up, so we can get rid of C and D. Okay. Now, second derivative is our acceleration, so that's 6t minus 8. If I put 1 into that, I'll get 6 minus 8, which is negative 2, so we're decreasing. So A describes what's going on there. All right, not too bad. Number 20 gives us this, and it starts to get us kind of thinking about some type of combination because we've done that a lot, but instead they throw a little curve. It says which of the following couldn't be found. So the first one says, could we find from 4 to 1? Well, yeah, that's just the opposite of what we'd have there. We could do that one without any trouble. Could we do 3 times f of x from 1 to 4? Yeah, that'd just be 3 times 8. That one's easy enough. Could we do it if we added these together? Absolutely. It's just one area and another. The one thing that we haven't done, and hopefully came to you, was C. We have not talked about what happens if we multiply these together, and that's something we wouldn't be able to get just from this information here. So C is our choice there. On 21, they give us a limit, and that should look familiar. This is in that delta x spot, and we see this quite a bit. This means derivative. And in fact, what they have is the function looking at us right here, sine 2x. So the derivative of sine 2x would be cosine 2x times the derivative of 2x, which is 2. And that's D. All right. And so we're not doing it at a point. Sometimes they'll throw a value in for x there and have us try to do it at a point, but not this time. Now we have a slope field given to us, and we're asked which of these would be the differential equation that makes that. So again, I just think it's always a good idea to kind of pick a point and see. So if you were to pick, say, 2, 2, we know that we should get a positive value. So 2 plus 2 is positive, 2 cubed, 2 cubed, 2 squared. All right, so that didn't eliminate anybody, right? Maybe let's go right here. This is the point 0, 2, and it's still giving us a positive, right? So if I were to put 0 in for x and 2 in for y, I'd get a positive here. I would not get a positive here. I'd get 0. I'd get a positive there. I'd get a positive there. All right? What about if I go here? This is the point negative 2, 2. If I put negative 2 in for x and 2 in for y, I should still get a positive, right? So negative 2 plus 2 would be 0. And get rid of that one. 2 cubed, 2 squared, still positive. All right, well, let's drop down. Let's go, say, right here. And this is the point negative 2, negative 2, and I'm still getting a positive, right? So if I put negative 2 in for y, I should get a positive. If I go negative 2 cubed, I'll get negative 8. If I go negative 2 squared, I'll get positive 4. So that's the one that gets the job done. Again, just pick some points, see if you should get a positive or negative, and see which ones do it, and just eliminate as you go. And then our last one here says, what's the average rate of change for this function between 0 and 3? That's a pretty simple one. F of 3 minus f of 0 over 3 minus 0 would give us 3 to the 4th, 81, minus 15. So, see, 71, 65, 6. I can do that. Put 0 in there. 0, 0 gives us 0 over 3. So 66 divided by 3 gives us C, 22. So not too bad.